Okay. So you are able to
Okay.
share screen, right? Everyone is able to see screen?
I think.
Yes, yes, yes.
Okay. Okay. Yeah, Mamita, you can
Okay.
start the project. Yeah.
Yeah. So, hello everyone. In this series, we are talking about the project personalized medicine redefining cancer treatment. So, before actually starting with the implementation, we are going to talk about the problem and we are going to try to understand it. Okay, so cancer has, as we know that the cancer has a thousand of genetic mutations, and these genetic mutations based on literature available in the medical domain. And what we are trying to do actually, we are going to classify the genetic mutation into one of the given 9 classes in the data that we have. So we have a, you can see that we have a, okay, we have a 9 classes, we have in the data, we have a 9 class. Okay, and so what is the actually challenge? So the challenge is we want to distinguish the mutations that contribute the tumor growth from the neutral mutation. And currently, the pathologist actually they do this manually. Okay, so they review and classify every single genetic mutations based on evidence from the text-based critical literature. But and from a business perspective, this is a very time consuming task. Yeah, so and it may take a lot of time, so time consuming tasks, and it may require a lot of resources also. So in this project we are going to develop a machine learning algorithm using all the knowledge base as a baseline to automatically classify genetic variations. So this is the problem. Now we are going to go through with the implementation. In this project, we are going to use Jupyter Notebook. As you can see, I am using the Jupyter Notebook for the implementation. Okay, so now we are going to import some model. Okay, and we have to do some installing the packages. Okay, so just wait. So here I am using the pip. Yeah, I am doing the pip install pandas. So it means the in Jupyter Notebook we have to install some necessary library packages. So that's why we have to install it pandas and pymongo srv. So pip install pymongo srv. That what is this? Right. So this is the mark is used in some Python environments like Jupyter Notebook to allow shell command to be executed directly from the notebook. So that's the way PyMongo do. Okay. And pip install Matplotlib. So Matplotlib, it's a as you know that Matplotlib is a necessity library for doing some analysis. Okay, so that's why I'm doing a Matplotlib installation and Scikit-learn and Project Pro. It's not important thing. NLTK. Okay. And now we have to import some necessary libraries from the model. Okay, so we have to do import Seaborn as a SNS, Matplotlib, and sklearn matrix. Okay. And now we are going to do import pandas as a PD. And this and you can do the pymongo also. Okay, if you want to do, then you can do the pymongo also. And okay, now here I am using I using some data from the my drive. Okay, personal drive. You can use on the Mongo PyMongoDB, or you can use another way also. And here you can see that this is the way you can install you can give the data from the PyMongo. Okay, so okay. Okay, now here you can see that here is a training test equal to PD read CSV. So we have to read the CSV file. Uh, this is the file. Okay, this code file we have to read CSV file. So here pd.read CSV, and this is my file folder path name. Okay, and here is the separate this is the pipe. This is the pipe option. Okay, you can see the data also, so you can understand it very well. Just wait. We have a so many type of text data that have a huge data. Just wait. See, there is this very huge letter. Okay, so we have to means extracting the data. We have to do that. This is the training data, and this is the training variance. That is the training test data, test variant, and test text data. Okay, so I can showcase the data also, so you can understand very well. Okay, this is the test data. So in test variant, we have a only gene and variation, but in training variant, we have gene variation and also we have class, right? And for the test text, we have a same huge letter word in the test text data. Yeah. See, there is a huge lot data. We have to extract and we have to do get dummies. Okay. So we have that type of data. You can understand now. So here skip row separate pipe means that skip the first row of CSV, which might be used if the first row contains headers or other non-data information. So that's why we have to do. And here is the engine Python. Here is the engine Python means there are the two engine in Pandas. One is C and another is Python. So it is used when dealing with more complex delimiter. That time we have to use the Python engine. Okay, and name and names means we are going to upload the data for training purpose. So that's why for the training ID and text, and here the skip row equal to 1 means we have to skip the row, means the first row we have to skip it. Okay, so that's why we just note down the skip row equal to 1, and then you can understand that if I just typing the training test dot head, then you can see that the first 5 data you can see, right? So this is the training data, training test data, and this is the training variant data. Same way I upload same way 4 data, like training variant, training test variant, and test text. Okay, so till now I think it's fine, right? Hello.
Yes, yes, yes. Yeah. Everyone is
Okay,
getting
so
right. Anyone has any question can ask. Yeah, Dinesh, you are asking something? Okay, okay, fine. All are good. Yeah,
okay, so
you can go ahead.
yeah. Ah, okay, now we have to do some missing 2 point in training menu. We have to do some printing the data. That means we have to check that how many length of the text of the Excel data. Okay, so if you run the print of the train variant length with the training variant, this rate train variant means we have means here I have print this name, this variable, this is the name I have using here, and length means the actual length of the data set. Okay, and training variant is my column name. So you can see that the for the train variant we have a 3321, almost 4K, right? We have a almost 4K data, and train text also same, and test variance we have a 5668, it's a huge data. We have to do so many model we have to do. Okay, so you can see that. Okay, so here training variant head, I am using the just check. Checking the first 5 rows, so that's why I am using these head options. And same way, this is the dot head. Okay, now we have to do some merging portion. Okay, so you can see that train data equal to PD means the panda. Okay, merging it is a PD panda dot merge training text and training variant on ID how left. It means that we have to merge training text data and training variant data on the ID on the base of ID. Common is the ID, no? So that's why we have using ID. And how it's mean left means we have to use the left joining, left merging. So that's why I am using here that PD merge the training text variant. And then I have to check that is null values any means the if any null value is there. If there is a false, that means there is a no null value. If there is a true, then that means it is a null value. So that's why we have to do the fill the NA value. Okay, so that's why I am using that filling NA value in text. So here I am using loc function. It is a location function. Okay, so I am means that I just evaluate this function in a train data dot loc, and train data text is null. Okay, is null dot text equal to train data gene and train data variation. Means if you have a if I have a any null data, we have to fill with the plus we have to fill some word. Okay, just wait. Okay, after doing the filling NA value, then I am just length, I have to check the length of the train data, and my length of the train data is same, 3321. Okay, now I am doing that train data dot head. It means that I have to showcase the first 5 row. Okay, first 5 row and first 5 column. Okay, now. Okay, now I have to check the testing test. So that's why I'm using print length test, and then I have to merge it. PD means the test data I have to merge at first, because we have a two type of test and test variant. One is test variant and one is test text. And for the training purpose, we have a training text and training variant. So that's why we have to merge in both together. Okay, for the doing some better analysis. So that's why. Okay, so here I am using test data equal to PD merge, same way on ID, and how it is a left joining. Okay, and now I have to check that this is the length of the testing test value, and then I am checking that is there any null value. If there is a null value, then I have to fill it. Okay, and then I have to drop the NA value, drop NA in place to me that if I have a extra data samples, so that's if I have a extra data sample, so that's why I have to drop it. Okay, so that's why I am using the drop NA. Okay, and now I am going to do that some data analysis. Okay, that how I will understand the data. Okay, so that's why I am using import NumPy as NT. Okay, you know that the in NumPy it is a very popular library we can use for the numerical operation and data manipulation, such as a handling array. Okay, and import warning, it means that allow the control of warnings message in Python. And matplotlib dot pyplot as a plt, it means it is a used for creating statistics, and it is a visualize purpose we have to use it. Okay, and Seaborn, it is a built on a top of Matplotlib and provide a high level interface creating visualized appealing and informative statistical graphic data. So that's why we have to use the Seaborn library also. So now we have to do some data analysis portion. It can help to analyze and learn about large amount of data from multiple source and detect pattern to make future trend prediction. So we are going to start variables by various feature and various feature. Okay, and we are going to start classes, which is the target. For each one, we are going to check the number value and we are going to print out a frequency graph. And we are going to take the some training data. Only for this analysis, we are going to take a class and we can check the link over there, and then the value of this check we have. Okay, we have to check it. So here you can see that this is the output. We have to print the data as a output number. Okay, and this is the I have to classify some basic things for the analyze the data. So that's why I am setting that the print equal to output number of the value classes. So see, it's print already there, and classes and print same and length class and print value of class is equal to classes. So you can see that the length of the class is 9 and value of the classes is it is a divide person, that 1 2 3 4 5 6 7 8 9. You already saw that this is the training purpose. See, this is the class variable. Okay, 1 2 3 4. That's where I am analyzing it. Okay, now you can see that the 7 class. Okay, if I okay, you can see that it is the 7 in the 7 class we have a so many data, and for 8 it is a less data. Okay, so it is a, I think it is a bar chart, as you know that. Okay, and see the 7 in the 7 class we have a 953 classes, and for in 8 class we have a only for 19 class. Okay, and same way we have to do the another also. Now second variable or feature we are going to do gene and variation. So for the gene and variation, okay. Okay, now you can see that the and that way I am using the Gini variation for the analyzing purpose, and you can see that for the Gini I have a number in 264. Okay, and here is the data set. Okay, and you can see that the BRCA1 is the highest data. I have a lot of data. Okay, and same way this is the variation portion, gene and variation. So in for variation we have a 2996 type. Okay, so now we have to import some basic necessity library for the doing a feature engineering. So this is that was the data analysis part, and this is now we have to do some feature engineering portion. Okay, so here import RE. Import RE, it is used for working with regular expression. It's help in finding pattern in string, making it useful for text cleaning, like removing special character, okay, unwanted pattern. So that's why we have to use that RE function, and this the import NLTK. It means that it is a which is widely used for NLP tasks such as a tokenization, text classification, sentiment analysis. Okay, from NLTK we have to use it, and from NLTK chorus import stop word. It means that stop words used basically what, like is, the, and, in, that type of word we have to means we have to remove it. So that's why we have to use this library also. And from nltk.steam import, here this library used to class from nltk.steam lemmatization. Okay, this is the process of reducing a word. Just like a if the swimming means the ing, right? So laminization doing that SWMI means they are showcasing only the swim portion. Okay, and swimming ing portion they will remove it. So that the library doing these things. Okay, and okay, WordNet. Okay, WordNet, it is used by the Lamatizer. It is a large database. When we are using this library, it is used for the large database. In the same way, understand the context word like noun, verb, that type of word, they are reducing it. Okay, and OMW, this is the same means the extraction of the data. Okay, means the MEs are that type of huge data we don't needed it, so that's why they are removing also. Okay, some basic library we have to do. So we have to do now for the some this lemmatization and stop word removing single character using. We have to do that portion. Okay. So here clean definition. I am using definition function here. Here definition clean text. It means a define a function name clean text that takes one argument text which is the input text you want to clean. So that's why I am using this function, and this is the normal print function. I have to use it. That the pre-process the text by following some cleaning step. Okay, that's not a big thing. Okay, now I am using the re.compile. Okay, so here I re-compile. It is a use to identify special characters such as the slash. Okay, single bracket, that type of word. They are replace them with the space. Okay, and then the bat symbolize compiles regular expression to remove any character that is not a lowercase. Okay, means the non-alphabetic symbol, number, that type of. Okay, and the limitizer, it is a reducing word to their base form, like running to run. Means, as I already said that swimming, you can use that. They are using only swim portion. Okay, that's type. And running, they are using the run only. So lemmatizing that's called lemmatizing. Okay, and now, okay, now we have to remove some stop word. Stop word means that is the is and that are the not a specific that are not a big thing for the testing purpose. So that's why we have to remove it. So that's why I am using the set stop word dot English. Okay. So English means it is a normal library. So okay. Now I am using the remove single character, and then I am using remove bad symbol and remove stop word and do some lemmatization. Okay.
Momita, is it something like sentimental analysis? Like we seen that I
Yeah.
seen like it's stop words like we are using.
Yes. Yes.
It's a
Actually, for
sentimental.
the
Hmm.
for the text data, you saw that, right? That this
Hmm.
is a training text and text data. So for the training text and text data, we have a so many text, right? You can see that. So we
Yeah.
have to remove these words. Okay, this and is
Oh,
in.
this word.
So we
Okay.
have to
Yeah.
remove it. Okay,
Mm-hmm.
then we can do the modeling process. So you can see that the see this is a use
Young
data by
character, right? So I'm
gene.
cleansing out the data,
Yeah.
right? Cleansing out the data, right? Cleaning data. Okay.
Yeah. Yes,
Mm.
yes.
Okay.
Am I going fast?
So how is everyone feeling, right? Are you getting, or you want like more explanation? Is it fine, everyone?
Yes, but little fast to understand the code, but yes.
Okay. Okay, you can explain once again, Mamita, right? From the
Okay.
little bit.
From the first, right?
I think from
No, not the first. First part we understand, right?
yeah, from
Somewhere you
where you
started.
want, like
Yeah, this one.
this one, the graph.
Okay, this data analysis person, right?
Yeah.
Okay, so for the data analysis portion, we have to import some basic library. Okay, so you can see that I am using import NumPy as NP and import warning, import Matplotlib and import C1. So there is a this is that library is a very means the big for using for the big purpose. Okay, if you are using from modeling purpose, means if you are using ML model to do some means the graph. Okay, so that time we are using that type of library, means NumPy is the using for the number analysis, and Matplotlib and for the normal bar plot, histogram, that type of. Okay, and C1 is the it is the upper the Matplotlib. Okay, this is the big means implementation we are using for the C1. Okay,
How about
and here
warnings?
I'm sorry.
Import warnings?
Yeah, input warning means if I'm input means warning, you can just wait. Okay. Uh, yeah, see, there is a when I am using the input re input nltk. Okay, there is a some red color means code error, right? So in this case, if there is a means if there is a remove, so that's why I am using this input warning, so they didn't showcase this type of warning error message. Okay, this is
Okay.
not a big problem. Okay, this is a simple thing, so that's why I am using the warning input warning message. Okay, na?
Yes.
Okay, and now you can see that I am using the print for output number and value classes. Means my in my bar plot, I am using the heading. You can see that the number and value of the classes. Okay, so that's why I am using the print option here, and this is the print number of classes and print value of classes. Means how many number I have for the class and how many value I have for the class. So see, number of classes is 9. Okay, you can see the data set also. So I have a for the training variant, I have a 9 class. Okay, so that's why I am using here number of classes 9 and value of classes is 1, 2, 3, 4, 5, 6, 8, 9. It is the division. Okay, so here you can see that this is the class for the x, and for the y it is a frequency. Okay, means the how much frequency I have for the classes. Here you can see that the 7 for the 7 classes I have a almost above 800 frequency. Okay, this is the very big, and for the 8 this is a very low. Okay, this is the you can see that, see you 90, it is a very low frequency, and for the 7 I have a 953, and just you can see that the 4 1 2 that type of frequency I have. Okay, and here name is count and data type is integer 64. So it is the data type name. Okay, so that's why d type is you're printing that int 64. So that's way I am using for the genie and variation. So gene and variation, you can see that. See, okay, wait. This is the gene, and this is the variation portion. So that in that way I am using for save analysis portion I am using. Okay, so see print output number and value of genes. Okay, you can see, and number of genes is 264. So I have a 264 of genes number. Okay, this is a huge, right? So you can see that for the BRCA1, I have a 264. See, for the BRCA1, I have a 264. Okay. See, that type of gene. Okay, I have how much I have the number. So that type is showcasing for the bar plot. Okay. And for the EGFR, I have a 141 that way. It's fine now? Is it fine?
Yes, yes, yes. Thank you.
Okay. And same way, I'm doing variation. Okay. Uh, this is the variation portion, gene, variation class. Already class and gene already done. Okay. Now I have to do the variation portion. So the for the variance, you can see that I have a almost 3K variation. It's a huge. Huge means huge, right? So wait. Yeah. This is the data. You can see that that the truncating mutation, we have a above 80% frequency, above 80 frequency, right? 93. For the deletion, we have a 74 frequency. For the fusion, we have a 34. That's why I am that's why that the analysis do that the for the Q6 1H have a very less, right? It's just one, I think. Okay, yeah, one. Okay. Now we have to do some means feature engineering. So that's why I am using here import RE, import NLTK. Okay, that way I am using some import library for doing the better result. So now we have to remove some character, okay, some word for doing the model. Okay, so that's why I am here. I am using some compile method, re.compile method, that they are removing that type of sign. Okay, single bracket slash. Okay, and then lemmatization. Lematizer, it is a use for the doing some cut the data. Means if you have a example, if you have a running letter, so for lematize, they can do that. They cut the ing and they are resulting the data only run. So it will the means the if every single word they are doing that type of thing. Okay, so that's why I am using the lemmatization. And here stop word means that the is and that type of preposition I have to cut it. Okay, for the doing model. And same way we have to remove some single character. Okay, just small character means the alphabetic character, non-alphabetic character, that type of character we have to remove it. So now you understand now?
Yes, yes, yes.
Okay. So there, that's why I am doing the clean the text file also, means, and length of statement is I am doing the training part, training data set. Right now we have to do the test. Okay, so that's why I am doing the clean text data, and you can see this is a huge data. We have to clean. Okay, length of sentences means the how many is the length of the each sentences. So let's say 39123704 is the use paper. Okay. Okay, now we have to do some model. Okay. Okay. So here y true equal to train data as type integer. It means that convert the class column to integer and store it in a y true. Okay. this is the integer, I have to convert it, and I have to store the y_true variable. So that's why I'm using y_true. And then this is okay. And del train data. Okay. This del train data, once the target class label are saved in y_true, this line remove the class column from the train data. Okay, so if the data is converted in the train data, so that time just delete it. They are using the delete portion. Okay. Now we have to do the split the data. Okay, for the modeling purpose, at first we have to do the extract set, and then we have to do the some analysis, and for the model tuning we have to do the split the data. So that's way we have to do the split the data. So here you can see that from sklearn model selection import train test split data. So we have to split the data train and test. Okay. So that's way you can see that the xrem. Okay, this is the variable name, and we have to split the data. Okay, here the test size 0.2. It is specified that the 20% of data should be assigned to the remaining set and 80% data of the training set. Okay, and for the second split, you can see that the test size is 0.5. So it means that if 20% for the test size, we are for the means the test size we have using, okay, test size we have using the 10%, right? 20, if I divided 10 20, so it will get the 10 or 10, right? So in 10 we have to do the same half. We have to do the half. So for the 10 we have the result is 0.5. So that's why this is the portion we are using for the test size, that 0.5. And now this is the print length, that x train data, x validation data, x text data. We are using that three type of deviation for the doing the modeling data. Okay. Okay. Now I am going to do doing some data analysis portion. Okay. So here you can see that the this is the means the division, right? X train and X validation and X text. So that's why we have to do that the some plotting purpose we have to do. Okay, that how much the classes are got divided. So that's why. So that's why I am using that. So here subplot is 136 size means the 15:6. Here is it is the subplot. Okay, and the peak size is 15 and 6 means the length and width we have to mention it. Okay, any number you can use it. Okay, and here I am using the set title. Here you can see that the frequency distribution of classes in training data. Okay, this is the title you can see. And for the adding label, I am using that for the set x label is classes, y label is frequency. Okay, yeah, classes and frequency. This is the one data. And for the histogram, I am using this is the histogram features. Okay, I am using it that the each color black, and for the bar plot width is 0.7. Okay, and width is 9. Okay. So that way I am using the analysis. So, okay, this is the training data, this is the validation data, this is the testing data. After splitting the data, we have a three data sets now. Okay. 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 Now we have to do some we have to do some modeling model. Okay. So here I am using for the Seaborn and Matplotlib and sklearn for the confusion matrix. Confusion matrix, it is a as you know that it is a means a very famous thing. Okay, it is a technique for summarize the performance of a classification algorithm. Okay, and why we choose the confusion matrix? Because classification accuracy alone can be misleading. So if you have any unequal number of observation in each class, or if you have more than 2 classes in your data set, so that's why I am using this. Okay, so and I am using, I have to use the log loss. Okay, you can see that for the modeling purpose, I am here, I am using confusion matrix, count vectorizer, log loss, accuracy score, classification reporter, logistic regression, TF-IDF vectorizer, and normalize. So I will tell you the purpose of every model. Okay. Okay. Okay, so now I will tell the I will just tell you that what is this. Okay, so for the count vectorizer, so what is it? The count vectorizer convert the text data into a bag of words representation by counting the occurrence of each word in a document, which can be used as a feature for ML model for the count vectorizer. Okay, and for the confusion matrix, it is a compute the confusion matrix which is used to evaluate the performance of a classification model by showing the true versus predicted class level. So that's why I am using the here the function means the function do. Okay, confusion matrix do that, compute the confusion matrix and divide the value. It's a one is actual and another is the predicted. And for the log loss, we just measure the performance of a classification model where the output is a probability value, and if I am getting the lower log loss value is the lower means the if the value is the below the zero. Okay, so it indicates that the better performance. If above the zero, I'm just showing, if the showing that the above the zero, it means that it's a overfitting. Okay, and around the 0 to 1, it means the underfitting. But below the 0, it is a better performance. Okay, it is a this is the log loss, and accuracy score. It is the calculate the accuracy of the classification model by measuring the proportion of correct prediction. Okay, and classification reporter, it is do that the generate detailed report showing the precision, recall, F1 score, and support for each class in classification problem. So classification report too. Okay, and TF-IDF vectorizer convert the text data into a matrix of TF-IDF, means the full form is the team frequency inverse document frequency. Okay, this is the full form for the TF-IDF vectorizer, and it convert the text data into a matrix feature. So okay, and PP matrix. Wait, not a PP matrix. Here you can see that normalize. Okay, normalize. The normalize do the scale the input data to ensure each feature vector has unit normal value. Okay, means that the length of each vector is 1. This is the often used to adjust for difference in scale between features. Normalized do. And tree, this is a decision tree. Okay, and tree input tools, import the tools from the tree module, which is used to build a decision tree. It is a very popular model for classification and regression. Okay, and the definition evaluate. Okay. No, I think no, okay. Sorry. No, I cannot read it. Okay, now we have to evaluate the model. Okay, so that's why I am here. I am using the definition function. So here the meaning is the trained ML model that is being evaluated. Okay, and test feature, that means the input features of the test dataset on which the model will make prediction. Okay, and white truth means the true level for the text data, and the data type is that the string data that can be passed to indicate the type of data being evaluated. Okay, this is the meaning of the data type. Now we have to do the predict on the test data. Okay, for the definition purpose we have to write the full of code, then we can execute it. So that's why I am just writing the all of the code. So here you can see that the evaluate different model using confidence matrix and log loss. This is the meaning of the all over the code. Okay, and predict the text data. Now we have to predict the text feature for the model purpose. Okay, so just wait. Okay, here I am using the pretty confusion matrix. Okay, so that's why I am using that CM equal to confusion matrix, white truth prediction, PRD. Okay, and prediction probability equal to model predicted probability, and it is going on the test features. Okay, and then I am doing that log loss value, calculate the log loss value. Okay, and now I'm just printed it. Okay, now we have to do that get dummy. This is the evaluate the model. Okay, this is the code for the evaluate a model. Okay, now we have to do the get a dummies variable. Okay, so we have the gene and variation, right? You can see that we have a gene feature and variation feature for the training data. So that's why I am using here training Gini feature one hot encoding. So one hot encoding that get the dummies extend Gini variation and drop first equal to true, means the here drop row the row is the deleted, first row is the deleted. So that's why I am using the here true. If I am getting to do the false, so they didn't work. So that's why I have to using here true. Okay, for the cutting the first row. And same way I am using the validation feature also. In validation feature I have to do the same, drop first equal to true. And now we use reindex to handle the unknown categories which did not appear in the training data. Okay, so so what is reindex, right? So reindex ensure that the one hot encoded validation data that has a same column as the training data. Any new gene not seen in the training will be assigned a value of using a missing those generated as a data. Okay, that's why we are using the reindex. And same way, I am using the for the validation Genie feature one hot coding, and test Genie feature. Okay. Now we have to run the logistic regression model. So you can see that here the logistic regression model, the log loss value is for the training data set, for the training validation and test data set. For the training data we have a 1.0.9. So it is not a very means the big result. Okay, it is not a satisfaction result because we know that the above the one it is a overfitting and below the one it is a underfitting. But if the value is the means the equal to 0, it is a good model. So you can see that the for the logistic regression, random logistic regression model, it is not a satisfaction, right? Because it is a overfitting. That's why the result is 1.1. Okay. And same way, now we have to use the method train variation feature, and once head coding and get the train data set, we have to get the dummies variable for the okay, wait 1 minute. Okay, now we have to do the concatenation, the gene and variation feature, because we just see that that the for the single gene and variation log loss value, it is a not a good fitting. So that's why the value is the you can see that the 1 point above the 1. So that's why we have to do the concatenation. Okay, and same way for the concatenation, we have to do the get dummies variation, and we have to do same way the re-index portion, then we can do that logistic regression. So here I am using the logistic regression model random state equal to 0. Okay, that for the random state equal to 0, it means the you just set the model for the one way. If you can set the random state equal to 2 or 249 or any another number, so your value can be changed. So that's why we have to use that random state equal to 0. That means it is a fixed number. Okay, that and it will not suffer. But if you using 30 or 100, so it will be suffer. So that's why. And you can see that the here the log loss value is the for the concatenation, the log loss value is 1.15, 1.76, 1.76. So here you can see that this is not a fair. Okay, this is also overfitting. Okay, so for the concatenation, this is a not a same. I think using the same code. Okay, so now we are using from sklearn dot text import the TF-IDF vectorizer. Now we have to do the text vectorizer. Till now we are doing that the training and training variants and training test data. Now we have to do for the testing data set. So that's why I am using TF-IDF vectorizer. Okay. So here the stopword in English, it means that the remove the special character and special word. Okay, and okay, just wait. Okay, and now we have to do the. You can see that this is the means the one hot encoding that we are using the same way. Okay, yeah, this is the validation variation, right? One hot encoding that get dummies variable. So that way I am using here. For the one word encoding, and then I am using normalizing the value. Okay, and then getting all the features name in a word. Okay, then I am using the x value text head, means the if means the I how much I have a value. So that's why I am using the head function, means I want to showcase first some head portion, means the 5 result I have to showcase. So that's why I am using the head portion. Okay, and then I am using the logistic regression model. So here you can see that the value is 0.9. So it is a, if I am doing for the text data, it is a good, right? 0.9, it is a preferable model. Okay, So 0.9 it is a best, and 1.2 it's not a same thing. Okay, it's not a good thing, and same for the validation and for the testing same. Okay. Okay, now we have to do to the data frame. Means if you can see that we have a, wait, we have a so many feature, right? Means the in the class we have a so many okay, we have a so many word, right? This is the word we can see that so many, okay, so many types. So that's why here I am using the data frame portion, where you can see that the train text feature to array means the I have to means transform the data from the array portion. So that's why you can see that it's all at the floating number. So 0.00, it's a very less number. So that's why it's using that type. Okay. And okay. Now you can see that if I have a 0, it means false. And if I have a 1, it is a true value. So that's way it is showing showing this table. Okay. This is for the gene variation. Okay. And now we have to do the PD dot concatenation for the gene variation and for the validation variation. Okay, so that's why I am using the gene variation concat portion. Concat PD dot concatenation. We have to do that concat the two values, two tables. Okay. Okay, after concatenating, we have to do same the logistic regression model. Here you can see that the log loss value is 0.5 and 1.0 and 0.9. You can see that you can understand that this is the good model because it is a 0.5. It's a very good thing because the value is satisfied. Okay, the model is satisfied. But for the validation data, it is a 1.03. It's not a satisfaction. Okay, so this is the logistic regression portion. So after doing the logistic regression, we have to do some modeling purpose. We have to do some modeling. Okay, that if I put the better result, if I could get the better result, so that's why I am using some modeling portion. So here I am using some modeling like a random forest and k nearest neighbor and navy space. Okay, so till now it's fine, right? So far, any doubt here? Hello? Okay.
Yes.
Any doubt?
No. You're just building those models data only, right?
Yeah,
Okay.
yeah. You understand now everything? Hello?
Yes, but
Yeah, you understand,
concept I
right?
understand it, but only thing is maybe those functions and all we're not aware of it, so just getting the
Means the which function I am using that
those are the
in that case.
models and all, yeah, the logistical models and all those models which I'm not aware of it.
Okay, for the logistic regression model, for the anything, for the any model, we have to at first we have to do some basic means the feature we have to do means the if we have to do some get dummies variable at first. Okay, after the dummies variable, so dummies variable, it means that they just means the removing the extra word, and they are just means means you can see that if the confusion matrix table, in a confusion matrix table you can see that there is a number, right? 0 1 0 1, that type of number. So dummies can do that they removing the word with replace the number, only 0 and 1. So that's why get dummies will do. Okay, and after the get dummies we have to do the logistic regression. Okay. So it is a advanced project. Okay, so I don't know how we will understand this. So you understand the basic concept, right?
Yes, yes.
Okay. Okay. So now we have to do the some basic. We have to do basic means the model purpose. We have to do the random forest and Navy's Bayes. Okay. And K nearest neighbor. So wait, I'll tell you what is random forest. Just wait. Okay. So yeah, we have to do the some basic model portion. We have to do some modeling. Okay, so that's why I am using here the random forest classifier. So what is this? The random. What is the random forest classifier? So it is a type of assemble the learning algorithm that uses a collection of decision trees to perform a classification task. Okay. So what is decision tree? So decision tree, it is a type of supervised learning algorithm used for both classification and regression tasks. Okay, this is the decision tree, and the structure of the decision tree. If you want to know that the what is there is a some structure of the decision tree. Okay, there is a some root node, leaf node. Okay, and decision node for the decision tree structure. Okay, and we have to we have to implement the k nearest neighbor model. So what is this, right? Okay, so knn model, it is a simple yet powerful algorithm used for both classification and regression tasks in machine learning. This simple algorithm store all the available cases and classify the new data or case based on a similarity measure. Okay, uh, that way it can do. And what is Navies Bayes? Navies Bayes, it is a simple way for a compute to classify things by looking at post example and applying probability. Okay, it is the probabilistic machine
Quick
learning
question.
algorithm.
How do you
Yeah.
how do we choose a model like this model is suitable for
Okay,
this set of
if
data?
you have a larger data set, then you have to choose the that type of model. Means if you have a see if you have a that type of hazing data, you can see, right, that this is the hazing data. Okay, you can use any type of model as you know that the concept. Okay, if you know that the here I am using the random forest classifier, so you can use it. It is the based on the data. Okay, if you have a huge data, then I have to use the that type of heavy type of model, just like a Navy's Bayes random forest classifier. This is working with the big data. Okay, so that's why we have to choose that model.
No, I understand that part, but there are a lot of models that will give you the same thing. How would you know that this model is very accurate and this is a model that gives the right predictions and
You have to implement all of the
okay.
models. Okay.
So there is no particular model will
No, there is no particular model, because we have to means that we want that the satisfied model result. Okay, so that's why if you are using the random forest classifier and your other person using the Navies Bayes. Okay, so you can see that for the random forest classifier you can get that you can see that the 1.60 you can get that result. Okay, for Navies Bayes they also can get that 0 point something. Okay, so it's not a means the correct way that we have to choose some things and we have to implement that. It is not a very big thing. We have to implement all of things depend on the data. If your data is big, so you have to use that type of bigger classifier, means bigger model. Okay, this is the random forest classifier, Navies Bayes. They are working on the big data, and there is a no classify all of this for doing the model implementation.
okay. So for any kind of such models, we have to implement all possible models and just
Yeah.
either okay.
Yes. You have to implement that. If you want, then you didn't want to choose that, you can didn't do that random forest classifier. Okay, it's fine. You can choose that the Navies Bayes. Here I am using random forest classifier, Navies Bayes. Okay, KNN for doing the means for the clarity of the data. Which model I have to get the better result. So that's why here you can see that I am using random forest, KNN, Navies Bayes, Gaussian NB. Okay, I am using that type of. You can use in your way depending
Okay.
on the data.
But how the data is being changing for each model? It's because of the sampling of the data has been
So
changing
we
or
have to first, for the modeling purpose, we have to doing at first the get the dummy. Means if you have the data in the string function, okay, you have to do that the integer int type. So that way you can get the logistic regression and then you can do the model.
okay, got it. Thanks.
Okay, na? So here I am using the random forest, Gaussian NB and Navies Bayes. Okay, so you can use your own way. Okay, so you can see that the max depth equal to 2. Okay, I am set the this model. I am setting the depth is 2. You can use is 4. Okay, this is the depth of the classifier, means how much they will how much they will finding the data. So that's why max state equal to 2 and random state equal to 0. As we know that the 0 means it didn't shuffle the data. So that's why I am using here the 0. Okay, then I am using the text variation and gene variation. Okay, validation data I am using for the training, validation and text data. So you can see that for the random classifier, that the 1.60, 1.64, 1.62, it's also it's a overfitting, right? We can see that this is the 0.52 for the logistic regression. We got the better result, right? When we do the gene and validation, when we do the concatenation, at that time when we do that, okay, that time we got the better result, right? That was the 0 point. So you can see that this is not a satisfied model, because this is a overfitting, right? So now I am using it. It is the same. Okay. So for the random forest classifier, and this is the KNN neighbor. Okay, the 0.69 for the training data. It's a good, but I think it is already the above the 5. So I think it is the underfitting. Okay, and 2.88 is the same thing. It's a very big, and for the testing data it is a 2.62. It's the same very big thing. Okay, And for the Gaussian NB, okay, so K nearest neighbor classifier. And then I am doing the Gaussian NB. Okay, for the Gaussian NB, you can see that the validation data is 18.34, which is not considered for the model. It is a large and huge data, and for the testing data, it is a 20.02, right? So it's a very huge thing. So as we can see that for the Gaussian NB, K nearest neighbor, and random forest, every model, this is a overfitting, and some this is that means the underfitting, right? Only 0.69 is some means the closing. Okay. Now till so far there any question?
No for me.
Okay. So now we are going to do some test logistic question. Okay, so it is going to take the model and then find and solve. These are the actually the parameter of the C and the solver. We are going to talk about now talk about now the C parameter and the solver. So what is C parameter and what is solver, right? So here the solver is the algorithm used to optimize and find the best parameter, okay, for the logistic regression model during training data set. Okay, and for the solve there is a various type of means the branches for the solver there is a various type of different function, right? Like in Newton, CG, SAG, Saga, and LBFGS. Okay, we have to implement in that type of the function. For the SAG, SAG, okay, this function it is efficient for the large data set and work well with the high dimensional data. Okay, for the SAG. And Saga, it is a similar way for the SAG, but it is get the more high dimensional data. Okay, for the Saga. And LBFGA, this is the same. Means it will Newton CG SAG Saga. It is differ from the data set. Means how big and how much data you have. So that way it's doing for the solver and for the C. Okay, here the C. So what is C parameter, right? See, penalty C, it is a control the regularization strain in logistic regression, which help to prevent overfitting by penalizing large weight value. Okay, if your value means for the penalty C value equal to if you have a 0. So it means if you have a 1, so it is a default value. Okay, and if you have C equal to 5, it means the less regularization, and this allowing the model to fit more closing the training data, which could increase the risk of overfitting. Okay, if the C equal to 5, if the C equal to smaller than C equal to 0.05, it means that the more regularization or more penalty for the large coefficient, making the model simpler and less likely to overfit, but it might underfit. Okay, means if you have a C equal to 0.05, it means the underfit, and with C equal to 5, it means the overfit. So that's why we have using two parameters, these are solvers and C. This is for the test logistic regression. Okay. So here I am using for the and 5 to 1, this is the size, and in solver there is a, this is the definition, this is the function for the solver parameter, and for the C parameter this is the function 5 to 1 5 0.05. Okay, so you can see that if I am running for the training, testing, and validation data for the parameter in the C, okay, you can see that there is a huge result. Okay, for the Newton CG. Okay, Newton CG is the same way. Okay, you can choose. It is the definition for the big data. Same. Okay, so the you can see that the 0.18 the value. Here the 1.24 and 1.19. Not a very means the satisfaction, I think, because 0.1 it is a very good. Okay, but 1.24, 1.19 it is not a very satisfying. This is for training, this is for validation, and this is for testing. Okay. So 0.5, here you can see that the 1.03. Now this penalty. This is for the SAG purpose. Okay, penalty 1. Then 0.5, 1.03. If you want to see that how much the model is good for you, means the which model is good for you, then you can, if the log loss value is equal to 0, okay, so it means that the model get you the better result. If the value is the above the 1, so it means the overfitting. Okay, and below the 1, it means the underfitting. Okay. So here you can see that the 0.3 it is a good. Yeah, that way we are doing that. And now we have to do the test data. We are doing right training variant, training test variant, and test text data. Now we have to do the test unseen data. Here we can see that the for the test variation, we are same thing we have to do. Okay, that same get dummies variables, get re-index. Okay, for that it is for test variation, and this is for test gene. Okay, and now you can see that I am going to do the vectorize and normalize, and then I am going to do the Gini variation, and PD contact means I am going to do the concatenation. Okay, we have to do that. The concatenation means the genes and variation. Okay, and then the test feature PD dot data frame and reset index. Okay, as we already know everything, right? And here you can see that the logistic regression is the random state equal to 0, and it is the parameter of the logistic regression. Okay. And now we are stating that the print predictive probability colon 20 means I want that the first 20 values, because you know that for the testing data we have so many means the huge of data, right? So that's why here I am using that the only first 20 data. Okay. So yeah, you can get that the result. Okay, so this is the whole process of my whole project for the personalized medicine project. Okay. So yeah, that's all about my side. Thank you. So any so far you have any question? I think.
So is it done, right, Amita?
Yeah. Yes,
Okay.
yes.
Anyone has any question? I'll share the recording in YouTube. Okay. And for the data set and how you will, can you give this notebook, right? This Jupyter notebook. Okay. To
Yeah,
me, and
I
then,
can share.
yeah, or put it in a Google Drive anywhere, right? So you can give the link, right? Later,
Okay,
right?
fine.
Okay. So that anyone can access this, and CSV file is needed, right? That data set, the 3 files.
Yeah, I can share the file and with the zip. Okay.
Yeah. Everything is in zip, so I will upload in Google Drive, and okay, I'll give with the video link I can give. So anyone can directly start this Jupyter notebook and then start practice, right?
Yeah. Yes, yes.
Okay, fine. Yeah. Thanks, Mamita, for your help and give this presentation. Okay, we'll implement it, and anyone get the questions so can ask, right, in the group. She's in the group also, so anyone can ask, okay, in the group, so she can reply, okay, related to this project. Okay. Yeah. Thanks, everyone.
Thank you.
Thank you.